quickly up here in the corner going to write the definitions for each of the trig functions that you should have gotten from the video that you watched last week. All right, it's sine theta equals y over r. It was cosine theta is equals x over r. Tangent theta is equal to y over x. And then the other three trig functions, which is cosecant theta, which was r over y, secant theta, which was given to you as r over x, and cotangent theta, which was x over y. All right, now you were supposed to watch a video last week which talked about that, introduced it, all that kind of things. All right, now what I want to make a connection here is, yes, you can use those formulas, all right, regardless of whether you use right triangle definitions or whether you use our definitions that are based on a unit circle, but in this case with a different radius, all right, you're still going to get the same answers. And it just depends on how you are going to want to visualize this, okay? So in a question where they say, okay, here's a point, negative 12.5, all right, it's on a circle with a radius with something other than r. R does not equal 1. Okay, so in other words, r does not equal 1. Find 6 trig values. Now I'm just going to do that. They are a little more wordy in your directions, but we know what we mean there. We're trying to find all 6 trig values. All right, so what this is a point. It's on a circle, but the radius is not r. Okay, so I'm going to attempt to draw that over here. Okay. Okay, so negative 12.5. If I were to plot that point, I would go negative 12, I would go up 5. Okay, negative 12, up 5. That's putting this point right here, negative 12.5, is in that second quadrant. All right, now, it is a circle. Okay, I'm kind of big on that, but it's a circle. It's on a circle. All right, and the radius, which would be from here to here, all right, I don't know what that radius is right now. Okay, now, it's not 1. Watch what I do. The bow tie triangle that we talked about. All right, the bow tie triangle in my second quadrant is this. So there's my right triangle in that second quadrant. All right, and from here to here is also the radius. From here to here is the radius. All right, it's halfway across the circle, so it doesn't matter where I draw it. All right, now if this point is negative 12.5, what's that mean? That means I started at the origin and I went to the left 12, or negative 12. And if I use that negative, then the signs of my trig function in the second coordinate are going to be correct. Second quadrant is going to be correct because this is a negative 12. I went negative 12 to get there, and then I went up 5. Okay, now the only value I don't know is that radius. All right, if I'm going to use these definitions, I need to know that measurement because this would be y over, this is x, this is y. So for sine, it would be 5 over whatever r is, y over r. Okay, or I could also use my right triangle definitions, so it doesn't make any difference. All right, but basically what this boils down to is, okay, I'm not on a circle with r equals 1, so I have to find the radius. That's got to be my step 1. Okay, so step 1, find r, and you're going to do that with just a good old-fashioned Pythagorean theorem. Okay, so negative 12 squared plus 5 squared equals r squared. All right, 144. Again, this is basic arithmetic. You guys can do this. I don't really need to be working all this part out. Let's see, that's 169. Okay, so then my r is 13. Okay, so my r is 13. So that value right there, this side is 13. Okay, so now I've got all my sides. I could use these definitions. I could also use my right triangle trig definitions. All right, now if I'm going to then find each of my trig values, here, let's go back to black. All right, I need to find sine. I need to find cosine. I need to find tangent. I need to find cosecant. I need to find secant. And I need to find cosecant. Or cotangent, sorry. Okay, so let's do right triangle definitions. Right triangle definitions, here's my theta. Right triangle definitions for sine is opposite over hypotenuse. All right, so I could do opposite over hypotenuse, which would give me a 5 over 13. Okay, so I could do it with right triangle trig. All right, or I could do it with y over r. All right, I'll write that here, y over r. Well, what's my y value? It's 5. And what's my r value that I found? It's 13. So it doesn't make any difference. This is using these definitions. The red right there is using your right triangle definitions. But because I know what quadrant it is, all right, I'm in the second quadrant. All right, sine is positive in the second quadrant. Okay, sine is positive in the second quadrant. So I got a positive answer. Okay. All right, let's go ahead and do the right triangle definition first. Okay, so cosine is adjacent over hypotenuse. So adjacent over hypotenuse, which would be a negative 12 over hypotenuse, which is 13. All right, so I could do it that way, or I could come up here and I could say, okay, I'm using x over r. Well, my x value is negative 12, and my r value is 13. All right, so I'm just trying to get you to see that you can do these questions more than one way. All right, and then if we go back and we look at, that chart about, what's the values, all right, well, cosine in the second quadrant is supposed to be negative, and my answer is negative. All right, the only two that's positive is sine and cosecant, which doesn't that make sense since these are reciprocal? And if this is negative, then this one will be negative. All right, depending on what I come up with here, which better be negative, it'll be negative over here as well. Okay, so let's use our right triangle definition first. Tangent is opposite over adjacent. So opposite over adjacent, opposite is 5, and adjacent is negative 12, which makes it negative 5/12. Put that negative in the top so it's not tacky. All right, but again, could I come up here and use these definitions as well? That's y over x. My y value is 5. My x value is negative 12. Again, moving that negative to the top so that it looks nice, okay, would be the way to go. All right, and again, tangent should be negative. In the second quadrant, it is. All right, now for these, again, you memorize these definitions, you memorize your right triangle definitions, or you know that these two are reciprocals. So this is 13 over 5. This is put the negative in the top, negative 13 over 12. And again, put the negative in the top, negative 12 over 5. Okay, so here, let's do this. Okay, this is right triangle trig. Okay, using those definitions. All right, and the blue is the quote unit based on a unit circle. Okay, so except not a unit circle here, but our unit circle are not equal to 1 definitions. Okay, so same problem. I can work in a multitude of ways. All right,